Hello everyone, we are going to do section 4.1, polar coordinates. Okay, everyone remembers what is Cartesian coordinates, right? Cartesian coordinates are defined position of the point on coordinate plane x and y. Usually it's two numbers, pair of numbers x and y, and you get x by drawing perpendicular line to x-axis, C intersection, and record the number, and the same for y, draw perpendicular line to y-axis, C intersection, record the number. There's another way to describe position of the point on the plane, which is called polar coordinates, and we are going to consider it. We start with drawing polar axis. Polar axis is just a straight line which starts at point O, which we are going to call a pole. Point P, any point on the plane, sits on some kind of line which goes from point O through point P. And there is angle theta, for which the polar axis and the line are going to be the sides, initial and terminal sides. The theta positive direction is counterclockwise. We also can measure distance from point O to point P using just a ruler along this line. And these two numbers are going to give us actually set of polar coordinates, distance and the angle. Example. Let's consider example. So somebody gives us two polar coordinates, 2 and pi over 4. How it's going to look on the coordinate plane, where the point is going to sit. Start with drawing polar axis. Then draw the angle pi over 4. On the line which defines the angle pi over 4, measure 2 units. And set up point P. That's going to be point which corresponds to this polar coordinate set. Another example. What if the first number is negative, which is like distance from the point? How do we kind of go over negative point? What are we going to do? There is a convention. How do we draw these negative points? First, we again start with polar axis. Then we draw our angle pi over 2. Pi over 2, it's a vertical line, right? Going to be 90 degrees angle. Then we're going to draw a complementary line to this one, to angle pi over 2. And on this complementary line, we are going to graph 3 units. We're going to measure 3 units. So pi over 2, the top side is for positive numbers, and the bottom side is for negative numbers. And that's how we are going to graph all negative distances. Okay, and we are going to get our point Q. Now, what is interesting? Polar coordinates are not unique. Cartesian coordinates are going to make a unique pair of numbers corresponding to every point. In polar coordinates, pair of numbers can be actually 2, 3, 10, 1 million different pairs of numbers will correspond to the same point. So, well, let me show you a couple of examples how it's possible. I'm going to graph my point P again, which I already had an example, and show you another way to describe this point in polar coordinates. Point P again with coordinates pi over 4 and 2. What else I can do? Well, I can actually consider angle theta, which is going to be 2 pi plus pi over 4. One extra circle. Still going to be correct description. And I'm going to get a point with coordinates 2, 9 pi over 4. And if I graph this point, I'm going to get exactly the same point P. So a set of polar coordinates is not unique for every point on the plane. What can be another way for it to be not unique? Well, let's graph point Q. Remember that point Q has coordinates negative 3 pi over 2 and sits kind of on the negative side of pi over 2 angle, right? 3 units. Now, how else can we obtain the same point? Well, what we can do? We can the counterclockwise direction of angle theta is positive. Clockwise direction of angle theta is negative. So actually it's negative pi over 2. I said pi over 4. And if I'm using negative angle, then the point Q sits directly on this side, right? So I'm not going to put any minus in front of it. And you see, two different representations for the very same points P and Q. Next, how do we convert polar coordinates to rectangular? Or like r and theta convert to x and y. Somebody gives us r and theta, and we'll need to kind of find x and y. Well, I'm going to draw first coordinate plane and then put some point in polar coordinates. Point has coordinates r and theta. How do I find x and y? Well, if I draw a right triangle, in this right triangle, x is going to be adjacent side and y is going to be opposite side. And r is going to be hypotenuse. So I can use this hypotenuse and angle to create actually length of adjacent side and opposite side. And that's going to give me r cosine of theta and r sine of theta for x and y. Let's consider a couple of examples. Please watch how I do them. Point is given like 6 and pi over 2. What are going to be x and y? I'm going to use formulas. Plug in numbers r and theta. Remember that cosine of pi over 2 equals to 0. I'm going to get 0. Well, 0 is a normal coordinate. Sometimes x equals to 0, right? When x equals to 0, something sits on y-axis. And I have the coordinates 0, 6. Another example. Minus 4 minus pi over 4. Well, again, I plug everything in and just use some properties of sine and cosine. For example, cosine of negative pi over 4 is same as cosine of pi over 4 because cosine is even function. And the final answer is going to be negative 4 over square root of 2. Now let's calculate y. And here, sine of negative pi over 4 is going to send the minus to the front, and we'll get two minuses in front, which is going to be just plus. And we are going to remember that sine of pi over 4 is 1 over square root of 2. Okay? So our answer is minus 4 over square root of 2 and 4 over square root of 2. So the point is going to be represented by this Cartesian coordinate. Okay, and now we are going to move to opposite problem. How to move from rectangular coordinates or Cartesian to polar. So rectangular to polar, or x and y to r and theta. Well, let's graph a point which has x and y coordinates. We remember that x is going to be like number at intersection, y is going to be number at intersection. What we'll need to find? R and theta. Well, I think for r everything is simple, right? Because we do have a right triangle, r is hypotenuse, so we just can use x and y as sides. And that's going to give us r squared, but if we extract the square root, that's going to give us r. Perfect. Now, how do we find theta? Well, from the same right triangle, we know that tangent of theta, for example, is equal to opposite side over adjacent, right? Or y over x. Take tangent inverse and find angle theta. Sometimes finding angle is going to be a little bit tricky. Major reason is that tangents are going to return thetas from negative pi over 2 to pi over 2. So if anything is greater than pi over 2 or smaller than negative pi over 2, tangent is not going to return it back. I'm going to give you correct answer. Let's consider point in first quadrant. Point has coordinates 2, 1. So let's calculate r and theta. So we have square root of 5, and for theta it's 1 over 2, or theta equals, well, I use the calculator, tangent inverse of 1 over 2, 26.6. So my coordinates are square root of 5 and 26.6 degrees. Example 2. I'm going to use the very same numbers, but I'm going to place a point in a second quadrant. Let's see how solution is going to change. So instead of x equals 2, I'm using x equals negative 2, and y is going to stay as 1. Let's see what is going to happen to my coordinates. As you understand, r is going to stay same because, well, no matter what are the signs of x and y, because they are always squared, we are going to get the same number if you have same numbers for x and y. For tangent, we are going to have negative 1 over negative 2, right? Which is going to give us tangent inverse of negative 1/2, which is going to be negative 26.6. If you look at my picture, you are going to see that negative 26.6 is going to be the angle, which is kind of opposite of what we have, right? It's going to make a straight line with what we have, but it's not actually our angle. It does not belong to the second quadrant. So how do we get actual angle? Well, you see that because they sit on the same line, they are different by 180 degrees. Okay? And we are just going to add this 180 degrees and get correct angle theta. So theta equals 26.6 was minus plus 180, which is actually subtraction, right? 180 minus 26.6, and we are going to get 153.4. So my coordinates in this case are square root of 5 and 153.4. Major reason, why does it happen actually, guys? Tangent really does not care what was negative x or y when you are dividing y over x. So it treats them same way. So if it was really x negative or y negative and x positive, it would give you correct answer. But because tangent really does not know what was negative, it's going to give you wrong answer. I'm going to move my point to the third quadrant, keep same numbers, but put some minuses in front. So I'm keeping x negative, and I'm going to make negative y. We know that the distance is going to be same, and the tangent is going to be now minus 1 and over negative 2, which is going to make up 1/2, and we are going to get again 26.6, right? We do remember that that's not correct angle actually, right? Because 26.6 belongs to the first quadrant, and we are sitting in the third. What should we do? Well, again, same recipe. Add 180 degrees and get correct answer. (206.6), and our correct answer is square root of 5, 206.6 degrees. Now, guys, I'm going to give you a couple of self-solved problems. Problem 1 is going to convert -2 minus 2 pi over 3 into Cartesian coordinates. And my second problem is going to be convert a couple of Cartesian points, negative 0.8, negative 2.1 into polar coordinates. I'm going to give you some time. You can stop my video and try to do it on your own, and then come back and check if my solution is similar to yours. So 1, 2, 3, 4, 5. Okay, for the first problem, I'm just going to use the formula. Plug everything in. Remember that cosine of negative angle is equal to cosine of positive angle, and 2 pi over 3 can be completed to 180 by adding pi over 3, which is going to give us actually cosine of pi over 3, but because 2 pi over 3 sits in the second quadrant, that's going to be a negative number, right? So cosine is going to be negative. But it's not negative because minus in front of 2 pi over 3, but it's negative because 2 pi over 3 sits in the second quadrant. We're getting 1 as a result. For y, everything is going to be similar, but sign of negative number is negative sign. So these two minuses are combining together and giving us plus. And we do have just 2 sine of 2 pi over 3, which is going to give us, we remember that sine of 2 pi over 3 and sine of pi over 3 are same because they have same y. So we're just, if you remember sine of pi over 3, it's a square root of 3 over 2. So we cancel 2's and get a square root of 3. So final answer is 1 square root of 3. Yeah, let's move to our second problem. In our second problem, we'll calculate r first by using the coordinates and squaring them, right? By the way, point belongs to the third quadrant, so we're going to have something similar to example 3. So I plug in the numbers and use my calculator and extract the root and get 2.25. Now I'm going to calculate theta is tangent inverse of y over x, and my y is negative, my x is negative, so totally we are going to have a positive number, 2.1 over 0.8, which is going to give me 69.14 degrees, right? I know that's not correct answer because it belongs to first quadrant, and we are sitting in the third one. So I'm going to add 180 and get my final correct answer, 249.14 degrees. Now I'm going to copy my final answer, and that's going to be all for section 4.1. Please do your homework, and if you have any questions, let me know. You can email me or just ask through Canvas. Thank you.